Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, and a 40 gigabit public network, you've got everything you need to run a fast, reliable, and bulletproof data platform. If you need global distribution, they've got that covered too, with worldwide data centers, including new ones in Toronto and Mumbai. And for your machine learning workloads, they just announced dedicated CPU instances. Go to dataengineeringpodcast.com/Linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. And you listen to this show to learn and stay up to date with what's happening in databases, streaming platforms, big data, and everything else you need to know about modern data management. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Dataversity, Corinium Global Intelligence, and Data Council. Upcoming events include the O'Reilly AI Conference, the Strata Data Conference, the combined events of the Data Architecture Summit and Graph Forum, and Data Council in Barcelona. Go to dataengineeringpodcast.com/conferences to learn more about these and other events and take advantage of our partner discounts to save money when you register today. Your host is Tobias Macey, and today I'm interviewing Anand Babu Periasamy about MinIO, the neutral, open-source, enterprise-grade object storage system. So, Anand, can you start by introducing yourself?
Hi, this is AB or Anand Babu Periasamy. I'm one of the co-founders and CEO.
And do you remember how you first got involved in the area of data management?
It was kind of accidental. I did not start out this way. Our original plan, it happened in my previous startup when we did Gluster project. Gluster, the name Gluster came from GNU cluster. It was supposed to be a shared memory distributed operating system. And within like 6 months of the project, our customers started telling that their problem was not computing. And they had petabytes of data sitting on tapes, and they wanted to move them to drives to do large-scale simulation. I actually could not find a good file system that I can adopt. So we actually built a file system from scratch. That's how I fell into this market. And once you come into data management, you cannot leave, right? Then I stayed on.
It's funny how many times I've had that conversation where the actual product that somebody ends up offering had absolutely nothing to do with the original intent of their business or their project. And it was just because they happened to build something useful that everybody else then started asking for that they decided to turn that into their actual project and company. Most notable that's coming to mind is Timescale DB.
Yeah. In fact, even the company name behind Gluster, no one knows. It's called Z Research. And at some point, Gluster became very popular because of GlusterFS. And we killed every other initiative, changed the company name to Gluster so they would recognize us. And Gluster became a file system. It being open source, if you built a good product, it gets noticed. And that's how it happened the last time.
And so now you can't seem to escape from file systems, and you have become the co-founder of MinIO, which is a different type of file storage. So I'm wondering if you can just start by explaining a bit about what that product is and some of the origin story behind the project and the business.
This time, while MinIO is an object storage, most people think that I am doing this because I became a storage guy and because of my past experience with the file system. That's actually not the real story. I was at Red Hat for a while after the acquisition to make sure the transition went smooth and they are able to take care without me. But what actually happened was I was thinking about doing something more fun. We were working on, me and a small team, we were working on bionics, like ability to see through skin. You can close your eyes and see things. Like I wanted to do something more fun. But then when it came to actually doing a startup, moment you have VCs involved, you want to do something that makes an impact the next 6 months, next 12 months. You want to show progress, right? And I went back to asking a very simple question, right? The object storage was an accident of that. The real question I asked was that, 10 years from now, what problem, if you pick today, will still stay relevant? Not only stay relevant, it has to compound and grow. And don't pick something that is trendy and short term. Where I looked, the direction was simply the world will produce more and more data. And it was never about storage, right? GlusterFS was about building a storage system. This time around, what I saw the problem was it's about data, and data will be the heart of every modern enterprise. And how you build a powerful brand of trust and love. And then I saw that everyone was struggling with just managing vast amounts of data. The closest thing they saw was HDFS and some distributed file systems like GlusterFS. And in 2008, it became quite clear, even while I was doing Gluster, that Amazon will convince the rest of the world that if you are willing to let go all the legacy interfaces like file and block, you can build a significantly better data storage system. And I knew that Amazon will convince the rest of the world. So I saw that building an object storage was a good starting point. My simple thesis was that if the data sits on a technology that we built, we can do many powerful things on top. And a good starting point would be to build an object storage. Everyone else thought object storage is a hard problem to go attack. And I thought that object storage is simply a distributed set of web servers, right? And we started out with object storage. And the idea being, if you are inside AWS, you should use Amazon S3. But if you are outside AWS, what choice you got? And that's the part that MinIO should address. And my calculation, and it's also a bet, right, is the world will produce so much data. What percentage of that world's data will be sitting on Amazon S3 compared to the rest? I saw that bulk of the world's data will be outside of Amazon S3. And I wanted to go give the rest of the world a powerful open source, better alternative to Amazon S3. And it turned out to be great. In the last 4 years, it really picked up virally.
So, in the object storage space, there are a number of different contenders, most notable being S3, as you said, but there are also products from Google and Azure, and then there are also some other open source offerings, most notable being the Swift Object Store, which is built on top of Ceph. And I'm curious if you can just characterize the overall landscape of object storage, both now and at the time when you were first trying to tackle this problem, and some of the main use cases that you see for object storage and how that has evolved over the past few years.
There is plenty of choices, and which is a good thing. But if MinIO is just yet another alternative to one of those file systems, if it's about like KDE or GNOME and Emacs and VI, there is really no good reason to just add another flavor to it. This is a market where users want to standardize on one system that is most proven. Because imagine like if there are many choices, you picked one of them because it came in your flavor, and then tomorrow the project is not well maintained, your data is going to be held hostage, right? The real reason why we had to do Gluster back then and this time MinIO is I actually could not put my own data in a system that was out there. Back when I built GlusterFS, it was about every other system was so complicated with metadata management. If you get corrupted, you're out of luck, right? It's a complex systems don't scale. And this time around, when it came to object storage, Amazon showed something very powerful, that if you strip down everything and reduce it to basic get put list type atomic immutable operation, you would actually be able to significantly simplify the whole object storage implementation. And everyone else I looked around, either they built a block store or a file system or a unified storage system and added a S3 object API gateway. If not, they are a SaaS product, right? Like Google Cloud and others are a SaaS product and they are incompatible with Amazon S3. What we wanted was something that is fully S3 compatible, and it is built for object API from the scratch. It did only one thing really, really well. Even some of the like Swift Stack, for example, Swift API, the fate of OpenStack itself, right? Like Kubernetes took off, and OpenStack has not made any dent in terms of like replacing Amazon for the rest of the private cloud. And Swift, to me, when I started, I asked the community that you pick Swift API versus S3 API, pick one. And it was very clear the industry wanted S3 API. And it's not just the API itself. If you look underneath most of these object storage systems, either they are a file block and then an object API gateway on top, or they have built a file system like storage system and then added a object API gateway. MinIO is a very different breed from the ground up. It is actually designed to be a single layer object storage system. I'll go into the details later, but it is by architecture, by implementation, it's a very different system. And how does it matter? Why it matters to the end user? It is really about a very simple system that can do very powerful things. So why is it important today? I found that the data is only growing bigger and bigger, and every enterprise today is struggling with the data management problem, and the performance and scale. Everything has grown many folds. The traditional systems don't scale to handle this kind of workloads in terms of performance and data reliability at scale. If you have tried any one of those systems, just installing them itself requires significant expertise. Then think about operating them at scale.
And another thing with Ceph is that, as you said, it has this API gateway for being able to provide the object interface. And at the foundational layer, it's essentially a distributed key value store for being able to store the bits and bytes of the files. But there still isn't any compatibility layer between the object store and the POSIX interface for being able to interact with the same files in a different format. So you don't really get any real benefit from running that system if all you really care about is the object interface. And because of the fact that it's adding additional abstractions, you're adding additional overhead as well. And I know that one of the factors that you're focusing on for MinIO in terms of positioning and feature set is the speed as well as the S3 compatibility, which I know is sometimes lacking with Swift. And I also noticed that a lot of your positioning is based around the use of MinIO and object storage for use cases around machine learning and artificial intelligence workloads. And I'm curious how you have seen the overall market for object store for those types of use cases as compared to a distributed POSIX interface.
So the use case part evolved organically as we watched the market in terms of the community, how they grew and what all they did with it. The AI/ML, if you noticed, if you track the history of the project, you would have seen that happened only in the last 1 or 2 years. When we looked at the use cases, it was all over the map, and as open source, you can't really control like what all they use it for. But what we found was that a bulk of the enterprise data was actually sitting in HDFS and very little on scale out NAS. In the public cloud, the shift already happened, right? Every major database systems, analytics, machine learning, if you look at them from Google BigQuery to Azure ML, Power BI, SageMaker, EMR, Athena, everything you look at, they are built on object storage. Private cloud is still sitting on HDFS, and users are struggling with managing that vast amounts of data and the complexity of HDFS and Hadoop. They want their on-prem infrastructure to reflect how AWS is built. This is where Kubernetes took the computing side, and they want object storage to be the data management side. And this drove the AI, ML, big data applications to MinIO's needs. And for us, because the performance was there, other object storage systems were eventually consistent, and the performance was not as good. Most of them are built for archival needs, right? Sure, you can put MinIO on a hard drive-based system, and you can use it for archival. It will be cheaper and faster for even archival needs. But where it really differentiated itself compared to other projects out there was the performance and the business critical needs. Simplicity is what the users liked. and we naturally gravitate towards that use case.
And then in terms of the S3 API compatibility, that provides a certain number of constraints where you are committing yourself to ensuring that you have this interface for the object storage. And I'm wondering what challenges you've faced in terms of ensuring the completeness of adherence to their API, particularly as it has changed and evolved, most notably being the S3 Select capability. And then also with the fact that you are accepting these constraints, what have you found to be the areas of innovation for the product?
So the good and bad part of S3 API, I would say it's mostly good. The only bad part is that it is not an open standard API, right? It is a standard simply because it's the most popular implementation, and I don't regret it because it is true for pretty much any system out there, whether it's your Apple charger or pretty much any device out there, any standards out there. If you are the most popular implementation, you automatically become the standard. And it's something that we don't control or the industry experts don't control. But I think it's quite all right that being somebody opinionated like Amazon, driving the direction and controlling it instead of consortium, I'm actually fine with that. Now, the details is where it mattered to us that if you look at the AWS REST API spec, the spec is just like a guideline, and how exactly the API is implemented, it is quite nuanced. The problem we found was that if you took different SDKs, different tools, even developed just by Amazon itself, right? Whether it's AWS Java SDK, different versions of the Java SDK, if you see from old to new, you will see that the implementation, the interpretation of the REST API spec is quite different, right? I wouldn't say quite, it's maybe slightly different, but different SDKs, different language bindings, they actually have different interpretations too. And you will also see open source tools. Sometimes they even have bugs. The tools that they have bugs, and the API on the server side needs to be forgiving. Amazon implementation of that S3 API, Amazon S3 service, that is very forgiving when it comes to a variety of applications, old and new, hitting the server. Now, when it comes to we mimicking exact compatibility, the challenge we have is it only takes one API to break. And it's not just one API, the APIs themselves have different variations and sometimes even bugs, right? We have to make sure that every single detail of it is captured. And we found that the only way you can get to that level of granularity and correctness is you have to be focused. This is where we decided very early on that do one thing really, really well. And and when we decided that it is S3 API, we never turned back, right? And the API itself within S3 API, if you notice S3 V4 API, we were the first to implement S3 V4. Everybody else either copied our code or they just copied our product itself into their product offering. And since then, anything Amazon introduced, like we will have it right away, right? Like you mentioned S3 Select, for example, like S3 Select only Amazon has and we have it. If anybody else has S3 Select, it is simply MinIO in their product. Being focused, we are able to catch up with Amazon. When Amazon introduced S3 Select, we were along the side, we implement S3 Select. In fact, before S3 Select, we had a more powerful implementation inside MinIO. Like you could upload like JavaScript as part of your REST call, and JavaScript gets executed on the data, and your output of the JavaScript attachment would be the output of the object. But anytime when Amazon innovates, we wanted to actually be closer and be compatible with Amazon. We constantly remove features, rewrite to be compatible with Amazon. It's only a good thing for the users because in the short term, like if I lock somebody to MinIO, in the long term, it's bad for the user. That is bad for us too. So we stay very close to Amazon S3 API, and everyone claims that they are S3 compatible, but the details is where it matters. right? For us, given the scale of adoption, that we are able to keep up with the S3 compatibility.
Continuing on the idea of data lock-in and providing a consistent interface to make it easier for people to move their workloads between different environments, I was also noticing the federation capabilities that you've built into MinIO, both in terms of federating between different clusters of MinIO itself, but also in terms of providing an API compatibility layer for placing in front of things such as Google Cloud Storage. And I'm wondering if you can just talk through some of the strategies and implementation that goes into that overall idea of federation and providing those compatibility layers to make it easier for people to migrate their workloads while keeping their client code the same.
Yeah. So the compatibility part, like an API gateway, it was relatively easy for us to do because of the design that we adopted inside MinIO. That even erasure code to Bitra to all those capabilities were at the object level granularity. So all we have to do was to make the erasure code module pluggable, so we can write other storage adapters and make everybody else look like Amazon S3 compatible. But the story behind how it happened is the interesting piece. Right? Microsoft actually was the first to ask for this feature. That Microsoft came to us and asked that if we can make their blob store S3 compatible. And I'm like, I showed them the data that how many MinIO instances were running inside Azure, and we were actually I think Azure was the third most popular deployment base for MinIO, and second is Google Cloud, and in fact, number one deployment base is MinIO. It's actually Amazon AWS EC2 EBS. There is like 600,000 plus, I think now 700,000 plus unique IPs of MinIO running inside Amazon itself. Now, when people are running inside public cloud, like I showed Microsoft that, look, there is already a lot of MinIO running inside Azure. So when people wanted S3 compatibility, they just run MinIO on your cloud. And what Microsoft wanted was something different. They told me that MinIO running on top of their EBS, actually on Azure, it was file and block share. That was not very useful for them. The reason being, if you uploaded data to MinIO on Azure running on a file or block share, that data is while you can read and write through S3 API, you can't run Azure ML or Power BI or any other Azure cloud service on that data because they don't speak S3 API. But what was interesting to us was they told that they can't even read the data sitting on their file and block. They're all built on object storage. And what Microsoft wanted us to do was to make MinIO store the data on top of Azure Blob Store. And for me, it's like, wait a minute, right? What you're asking me is to put object storage on top of object storage. Why would I do that? And they explained to me that all other cloud services inside Azure only speaks Blob API. The second part was they treated file and block to be a legacy, and we storing the user data on a file and block was meant to be an enterprise legacy compatibility layer, and that it made sense to us. And besides, we also saw that the need to make every other system that is not S3 compatible to become S3 compatible it solves a very important problem for us, right? Today, the biggest problem that industry is facing is applications are still speaking legacy API. They need to be rewritten to be cloud compatible, and every cloud being a different API is not helping it. If we made everybody look like S3 API, more applications will be speaking S3 API, and it will enable the migration to whether Kubernetes or MinIO or public cloud, or pretty much you want to stay with your existing even legacy, like say your NAS and SAN systems. We can make even them look like S3, even HDFS can look like S3, Backblaze, Alibaba Cloud, like Google Cloud. We made everybody look like S3. And now what it did to the industry was made a huge amount of applications adopt S3 API as a standard, while one side Amazon helped tremendously. We actually helped the private cloud market adopt S3 now that there are more applications, and they also see they have been built on MinIO in most cases. And when they go to production, they just carry us along with them.
That's funny that it was actually a request from Microsoft that led to this feature. And I like the point that you made as far as the S3 API is more than just the storage, because by allowing people to interface with these other object stores, such as in the Azure case where that's all the other services know how to talk, or in the Google case where you're able to load data into the Google Cloud Object Storage and then from there directly load it into BigQuery. It simplifies adoption of not just the storage system, but also additional services and capabilities that you wouldn't necessarily think of at first.
And you can see right there, it doesn't really help us at all. We are actually helping Google Cloud or like other public cloud services. But I think in the end, if you do what is right, if you are altruistic, it actually pays off. It is profitable to be altruistic.
One of the challenges I'm sure that you faced on that front is how to map some of these S3 APIs, particularly the select capability, onto the other object stores that don't necessarily have them natively. And I'm curious how much effort that was and how much involvement you've had from those different companies in terms of either working with you to add those capabilities to your code base or in terms of modifying the capabilities of their platforms to make it easier for you to implement.
So there are actually some minute details that matters. Like say, for example, say whether it's encryption, S3 select, like features like that. The way we did it in the gateway layer is if the backend does not support the functionality, and if I supported it, then if you directly go to the backend, can you read the data? Right. This is actually this detail matters a lot. What users really want is we have to be a transparent layer on top of the existing system, whether it's an existing cloud storage provider or a NAS like NFS mount point, or even your ZFS. Even SAN vendors do that. What they really want is your existing data. Say if you mount your NFS volume, if you already have say 2 petabytes of data sitting on your NFS volume, you're not going to migrate that data to MinIO. If I write the data in a proprietary format on your NFS, if you can access the data on S3, like I mean through MinIO as a S3 compatible object, but if you go to the backend directly, it will be all binary blob type data, and you won't be able to access them. That actually is not a good idea, right? So what really people want is whatever data they put through MinIO is written natively like a file on NFS or a GCS object in Google Cloud, or if it is a blob in Microsoft Cloud, we need to translate it and write it natively to the backend. Now when we do that, some features that the backend does not implement, like say for example, even the encryption APIs that Amazon has, SSE server-side encryption, client-supplied keys, and SSE, S3, and KMS. I can't really do a full translation to the backend. Now, if I encrypt it at our gateway layer, the catch is that now I have encrypted with MinIO. Now, if we go to the backend directly, the Blob API won't know how to decrypt the object that we encrypted. So, how did we handle cases like these? So we actually implemented the functionality in cases where we can translate it completely by somehow masking it. We actually did it transparently, but we never wanted to write it in some proprietary format. Encryption is a case where actually some of the large financial customers, they wanted the data to be encrypted before it left their data center, and they were using public cloud just as a DR copy, so it made sense for them to use the encryption feature. But for the rest of them, generally what I tell is use the features that, like, object storage has nowadays object storage has like it has more features than you need. Generally don't pick features that are very specific, that if you move to some other, let's say if you move to Azure, to Google Cloud, and if you are going to miss that feature, it's okay for you to not use it. Be like it it's really important to not look at some features that will hold you back hostage. If you use it, you have to have a very strong reason, right? In our case, what we did in with MinIO being a complete alternative, we were able to catch up everything that Amazon has that the rest of the world needs. In fact, some cases that like worm like capabilities, we were able to add more without breaking the compatibility. But for the gateway part, that it's not possible for us to mimic like a subset of the APIs without breaking the idea of writing the data in a native backend format. So we implemented them as options. Then the users are pretty knowledgeable. They know how to turn it on and off depending on their needs, and we have good guidelines on how to make these choices.
In terms of the actual implementation of MinIO, I'm wondering if you can talk through the overall system architecture and some of the ways that it has evolved, and then also some of the additional services that you've built alongside it, because I know that you have replicated some of the functionality around the key management store and IAM, or identity and access management, and just some of the overall sort of tertiary projects that have come to be necessary as you evolve the overall capabilities and reach of MinIO?
So this architecture is where it fundamentally differentiates. It is also the reason why we saw that the object storage was the right starting point for us. If I am going to implement yet another textbook theory of object storage, it wouldn't be any better, right? Other than cosmetic reasons. What I saw was that when you look at the S3 API, it is simply a get, put, list type atomic immutable web service API, right? And if that is the case, your entire storage stack could be just reduced to a web server. And what MinIO is, if you have noticed, like you just download the static binary and run. And if you have a distributed set of machines, you just download that same binary to all the machine and type same exact command line, and they all cluster themselves up. There is not even an installation process, right? It's a static binary, download and just run. That is where the real differentiation starts. It is a web server at its heart. All of the storage layers got collapsed into a single layer. Everybody else, if you look at the design, there is a distributed block layer that handles erasure code or replication or whatever. Then there is a virtual file system layer, and they have a multi-protocol API gateway on top. And this is where they get it wrong, right? They end up actually following the same old file system theories that are not applicable today. I felt like the same arguments that when Gluster was implemented in user space, even the kernel hackers thought that user space file systems were toys and we would never be able to give a meaningful file system. But in every benchmark, we showed that we were faster than the kernel file system. There were no good kernel-based file systems out there. And now I see the same thing got even more simplified. An object storage server is actually not a file system with a API gateway that speaks S3. Instead, it's actually an object storage server is a web server. A distributed object storage system is nothing but a collection of web servers that are stateless, distributed, and cooperating, right? So we by collapsing everything into just a web server and all of the storage functions, like then what about erasure code, locking, like a bitrot check, encryption, all of these functionalities. Where do they go? They are simply web handlers attached to the web server. Literally, the muxer, as soon as the entry comes, the API entry comes, it decodes the S3 API. Mostly, they are XML content as part of the HTTP request body. It translates that into a generic object API, and then when the data comes, it simply atomic blobs of the object. You erasure coded or bitrot protected, your encryption or whatever you want to do, they are simply transformation stateless functions. Once an object is erasure coded, you got collection of blocks and you scatter across other web servers. It's a really simple design, and that is what made MinIO a very different breed, because there is no multiple layers to hop, there is no metadata database, and it is a collection of web servers with a cooperating distributed lock. And this made it very resilient, very high performance, stateless. You can crash a system in the middle of busy workload, you won't lose any data. There is no caching. There is no eventual consistency. Everything is committed. In fact, we even write to the disks with ODirect turned on. So we are not even relying on the disk buffers, right? You could lose power on the data center and data can get corrupted because XFS did not journal the data. We don't want to run into those kind of problems. It's really a simple architecture, and that is what made MinIO different.
So, can you talk through the overall clustering strategy that you use and some of the way that you actually manage the file metadata, given that you don't have a centralized storage layer or database for being able to reference that?
So the centralized data layer came from the legacy idea, right? A file system historically meant translating a POSIX-like operation into collection of blocks, and then once you break them into collection of blocks that are mutable, then you need to have the association of what blocks make an object and what all objects are in which bucket. That's where the metadata comes, right? We actually did not find any such need. When the blob comes into the system, so within the MinIO architecture, the concept is like this. Every 16 drive, this is a default setting, you can override if you want. Every 16 drive is a erasure set. And then when you have a collection of machines, a cluster is or a server set is a server set is a cluster, and within the server set, say if you have 32 servers and each having 32 drives, you have 1024 drives, right? Now, what MinIO does is it deterministically picks 16 drives, making an erasure set. And when the object comes, it actually breaks it into parts and then places them on the 16 drive set. Now, a collection of objects in a bucket, it actually picks different drive sets. And whenever the object comes, the location of the object in terms of which drive it has to go to is simply a hash mod operation on the object name. Object names are unique across the namespace, and a hash mod operation deterministically places the object on the same exact 16 drive set each time. Now when the request comes to any one of the server, each of the server has the same logic. It's simply a deterministic lookup algorithm. It doesn't have to check a metadata database, and also all object data and metadata are written together. By doing that, you actually have a significant advantage in terms of resiliency and performance, because you don't need to hold a lock in a central system. Here you have to hold almost a global lock, because you need to make sure that the metadata database is updated. We have no such requirement. Each object is granular and completely parallel. There is no global lock here. Each object, because the object names are unique, it holds an object level lock and then takes the data. Often the data comes in bits and pieces, like get object range or put object multi-part. All of them are committed atomically by erasure coding and scattering across the drives. The location API is simply deterministic. So within a cluster, this is how it behaves. Now, what happens when I have multi-data center, multi-cluster? That is when different regions behave like exactly Amazon AWS regions. Depending on the bucket location, your request gets forwarded to the right cluster, and within that cluster, the every one of the node in the cluster is fully symmetric. There is no metadata name or a name node like property here, right? Every node is equally capable. Once your bucket location tells that this is the cluster where your bucket is, that cluster, any one of the node knows how to exactly serve the data. It may be a little hard to grasp without a picture, but think of it as you wrote a simple web service for file uploader and file getter, right? You would find that you will actually gravitate towards this kind of model very closely. And the only difference would be if you don't have to remember the the location in a database, how would you do? Simply use a deterministic lookup algorithm.
So how do you characterize MinIO in terms of the axes of availability and consistency on the CAP theorem? And how do you handle network failures in that clustered context to ensure that the blocks that you're trying to write to based on these modulo hash operations are going to be accessible at the time of the commit?
Yeah, so when I designed the system, I never thought of the cap theorem based approach. It makes sense when you are actually doing a replication model, where when you are doing a scale up or a replication, like where these problems comes into the picture, and you need to make a hard decision. In case of MinIO, just to map it into the cap theorem, what is our model? I would say that it is CP. A consistency is actually very important that most people don't realize. Eventually, consistent systems, just before the data is propagated, the drive that holds back, say, uncommitted data, it's not yet erasure coded or it's held in the cache. If that drive died, the odds of that drive dying is higher than the other drives. Uncommitted data leads to huge operational support problems, and it is really important to actually be done with it and let the application know exactly what failed. And we took consistency very seriously, and also partition tolerance. I think it is no go. You can't really you can't be forgiven if you make mistakes there, because in any system it's okay to actually fail but not corrupt the data, right? Any storage system, this assurance has to be there. So partition tolerance and consistency is super critical. Now when it comes to availability, now here is where I think the cap theorem is not well understood by most architects, that not all are equal all the time. It depends on the type of distributed system you design. And in our case, the availability part, here is where erasure code comes in handy, and a combination of erasure code and the S3 API itself, that the concept of S3 API being atomic and immutable in nature, application remembers the context, right? And object storage system, every operation, as long as I commit it atomically and I continue to keep that atomicity, then I'm good to go, which means that I only need to take care of metadata updates and data updates. Because there is no metadata database, they're written together atomically. I'm able to actually solve these problems more elegantly. Now, how are we dealing with the availability problem then? Here is where, when you take an object, break it into multiple parts and spread across 16 drives, across 16 servers, you have plenty of parity nodes. If I have, like, say, 4 parity, I can lose up to 4 nodes and my data is still available, because erasure code and the very nature of S3 API and how MinIO is designed, we got plenty of availability to withstand failures. That's the part that it is completely all right to compromise. So we did a CP system here.
For somebody who is deploying MinIO, what are some of the operational characteristics and server capabilities that they should be considering? And in the clustered context, how is the load balancing handled? Is it something that you would put a service in front of the cluster, or is that something that the nodes themselves handle as far as routing the requests to the different nodes within that cluster for being able to ensure a proper distribution of the data?
So the way we designed it in MinIO is that the nodes themselves should handle all the routing, but it's not always the case, right? So when do you really need a load balancer or a service machine in front? It depends on the use case. So I find that when people deploy this in case of the AI/ML, like data processing workloads where they need high performance, every hop counts, and usually these applications are running along the side of MinIO over 100 gigabit Ethernet and NVMe. When they do that, you want the fastest path to the data and shortest path to the data. And NVMe and SSDs are all about how the time to first byte. And in that case, they go directly. And any one of the node you hit, they all have the same capability, and it's fully symmetric. So you I wouldn't recommend putting a load balancer there. Now, then how do they discover which node they want to go to? It is simply say if you have a 16 node cluster or say 100 node cluster, you simply have these node names mapped as DNS, and a simple round robin DNS based approach. The clients are spread uniformly across all the servers and they do the job. And S3 API is quite resilient in terms of even if the server restarts or anything, they actually reconnect. HTTP itself is a stateless interface, right? Now, why do you then need, when do you need a load balancer or a service mesh in front? When you are actually building an application use case where you are using this like a photo store or some mobile application data that they are accessing across the internet, so what I commonly find is they want to have a layer that does SSL termination, like bandwidth throttling. There are multiple other reasons like routing and service discovery. So there I actually see almost like two classes are emerging here. The slightly old school, I don't know if I can call them old school, but it is the most common approach is a load balancer approach. The emerging one, particularly the large scale ones, are actually switching to a service discovery model. Here is where Istio, Envoy type. There are actually multiple solutions out there in the market. Smart Stack. They actually I evaluated a bunch of you here. If you are building very large stack, there actually the service discovery part actually takes care of scaling. Like as you add new clusters, they get registered automatically and applications discovers these capabilities. But then when it comes to actually hitting the data, they don't want to go through a load balancer. This is where like Envoy, like sidecar proxy brings the load balancer almost like a personalized proxy closer to the application. These are some really cool emerging ideas. If people are building large scale application like SaaS applications, they would go this route.
And in terms of the project itself, I'm wondering how you approach the ideas of project governance and sustainability and just some of the overall strategy from a business perspective of having it be open source.
Yeah, actually, this is the one that close to our heart. And while we are doing startups, the reality is for us that when we did Gluster last time, the team came together because they were passionate about open source. In fact, while I call open source, we are the free software guys, right? You know the difference, right? And the GNU,
free as in speech, not as in beer.
yeah, exactly, right? It was out of passion that it grew. But when you build products with passion, the attention to details and craftsmanship, they get noticed, and that is how it led to success. Not because we are a bunch of entrepreneurs, we wanted to make money and we got together and figured out what will make most money. It didn't happen like that, and because we were passionate about open source back then, I call it open source simply. It kind of hurts me when I say open source every time, but when I say free software, being a purist, very few people really understand it. But the truth, end of the day, shows up, right? Gluster is the case, and MinIO is the case. You see, there is nothing proprietary here. It is 100% pure open source or free software model. And why it matters, like back then customers used to ask me like, hey, open source means it's inferior, or is it's not secure. They used to ask all these questions, and it has come a long way. Now you can see even VMware has to look like Kubernetes and embrace Kubernetes. Every large deployment, particularly in the data space, that we find customers actually are mandating open source for their infrastructure because they have seen even big companies killing products, shutting down every few years on these products that enterprise depend upon. With open source, you can easily hire top talent across the world, and it's no longer a problem, right? Now, when it came to governance, now how do we run our work across compared to other open source projects, we took a benevolent dictator model, right? In fact, it's not a pure benevolent dictator. I would say it's like benevolent dictators all the way down, right? My job is to make sure that I continue to groom more and more leaders. Everyone in the team is empowered to make decisions within their scope. The hardest part for me is it's like you have one giant canvas and you have a bunch of artists, and our goal is to create one piece of artwork, right? One mind. It is not quite, it's not easy, right? But you have to be opinionated and you have to bring everybody to see the same vision, and this has to extend beyond our team into the community. Right now we are able to see the scale at which we grow, like 324,000 downloads a day. Maybe some of them are CI/CDs, but by all measures, our like say 5,300 members on our Slack channel, every like 18,000 GitHub stars. Any number we look at, we have deep penetration. But the key here is we are not an Apache Foundation or a Linux Foundation project. What I found was that the moment you bring in a consortium and a board, you have multiple chefs, and then every vendor has their own commercial interests. It becomes really hard to drive a project. I found that being a benevolent dictator model, being opinionated, if you are true to your cause, you will be able to build a powerful community. And the community showed faith in us that they don't need a third party non-profit organization to endorse that we are a company that we can be trusted. And they have seen this even in the past. Like Gluster, I'm no longer involved, but it is a project that is still thriving without me or even some of the core members, right? That is the one that's giving users a lot of confidence that we understand what we do, and we for us, open source is not a business strategy. It is a philosophy we believe in, right? And they're able to see through that. And combined with that, you also have to build product with the craftsmanship, like thinking like an artist, a minimalist culture. If you establish the culture, that culture is the one that actually brings the right kind of people together. And once you bring those people together, then you can't stop it, right? It becomes a way of life for them, and they get emotionally attached. Some of these guys, that wherever they go, they are almost like attached, emotionally attached to not only MinIO. Everything they do afterwards, they want to do it like this. That is the one that is giving the stability for governance and the stickiness and sustainability for long term.
Yeah, it's definitely great seeing businesses that have that understanding of the ethos and culture of open source projects and ensuring that they're actually in it for the technology itself and not just for the business opportunities that come along with it.
Yeah, no, like we are kind of fortunate now that because the industry has come a long way, you no longer have to convince the customers that why open source and free software is great for you. Now they are telling us that that is all they need. In fact, like the surprising part is even investors are actually favoring open source, particularly in the enterprise space, infrastructure space. They favor open source over proprietary startups. Even investors are advising these proprietary software startups, entrepreneurs, to actually consider open source. And the problem is that you have to believe in it, right? It's not something that you think of it as a business strategy.
Because of the fact that you have gained this measure of popularity, I'm sure that there have been some interesting use cases that have come about. And I'm wondering what you have found to be some of the most interesting or innovative or unexpected ways that you've seen MinIO used.
Okay, that's actually the fun part, right? I can say this is a true private cloud use case, like literally. Right? This is MinIO running inside Royal Caribbean ships because they have no connectivity. I've seen even similar cases like movie production. They on site they have to capture, and they also the raw videos are so huge, and they need to do all the editing and processing on-prem. And from cases like that, like the one that surprised me the most was that 700,000 unique IPs of MinIO running inside AWS. Right? I don't know how many of them are seriously like growing. I kept telling these users that they should be using AWS S3 when they are inside AWS, because they are running us on top of EBS. EBS, I think, is like 3 times more expensive than S3. You're not really saving money by running on top of EBS block storage. When I spoke to these users, what they were telling me was that they wanted cloud portability. They have fully automated their stack through Kubernetes, and they are able to burst their deployment into public cloud, whether it is CI/CD or application development. They are able to move between clouds. It is portability and convenience is more important than the cost. But I would, if you ask me, I would still recommend that if your data is growing, you either stick to S3 inside AWS. If you're outside AWS, then MinIO makes more sense. Then the one that recently came that was quite interesting to me was the Tantan use case. Tantan is like Tinder of China, and they have like insane amount of really small files. These are like sub 100K, and the largest they can ask is like 200K type object. And when you have like few kilobytes worth of objects, you should really not be looking at object storage. You should be storing them in a database. But the problem is that they had petabytes of such data, and no database would scale that big. So what they did, interestingly, was they changed our drive FS layer with RocksDB, so they can actually store petabytes of really, really small files that should actually be stored in a database. Instead, in this case, it's stored as objects, and the objects are indexed as collection of compacted RocksDB databases. And essentially, MinIO doing erasure code, bitrot, all those capabilities with strict consistency across many nodes at petascale. This is almost like a distributed database with a S3 API. That actually surprised me. If they had asked me on their own, I would have completely discouraged them. And this surfaced after they were running us in production at scale, and they published a blog post recently, and it came as a surprise, and I'm actually encouraged by it, the innovation that they did. Then I also see from medical imaging use case, usually they are the one that is like most conservative. All the VNA, vendor neutral archive, and PACS data they are storing. Like 12 of the 15 largest banks in the US are using us. Like 13 of 15 in the Europe is using us. We found that the organizations that are supposed to be conservative are the ones adopting open source object storage. I think that they have come a long way, and also I think they're struggling with the data explosion problem.
Yeah, it's definitely interesting sticking a file inside a database, inside an object storage, to be able to query it at scale.
Yeah, you know exactly what I mean.
In terms of the future direction of MinIO, I'm wondering what you have planned in terms of the product roadmap and any additional projects that you may build to incorporate with the object storage and provide additional capabilities.
Yeah, so some of the newer things that we are working on, more and more, I see even the databases are coming to object storage. That actually also was a surprise to me, right? Initially, I thought databases and object storage are parallels; they should be running side by side. But because even the small data is growing big, from Splunk to Vertica, Teradata in the proprietary world to open source, you will see all the way from Presto to Spark ML to all the like Drill. All the databases are turning to object storage. They're leaving their storage backend to object storage and working on just the SQL processing and query engine. So that working with these guys in terms of integration, validation, that's just a matter of ecosystem, right? In terms of enabling more and more richer applications to come to object storage. But in terms of features inside MinIO itself, the most important thing that that I care is actually supportability. Supportability in the name of how do you really operate a large infrastructure at scale with very little expertise. As you scale bigger and bigger, if you need to hire more people, then you are not scaling at all, right? So how do you then do that? This is where I see that supportability is not a separate problem. It is very much a product problem. And you would have seen like even some like recent features, like simple things but they are very powerful features, MC admin trace. It is like the dtrace type but for an object storage, that when you run a trace, it's as simple as like admin trace command, you point to a running system, then every single operation that is going on at that point, it will give you with details. Anytime when application has some bug or it's a bug in our code or something, like this is where S3 compatibility, right? If something that we broke or some new application is using some kind of legacy API that or they're invoking it in the wrong way, run admin trace and immediately we can tell bug in their code, bug in our code, or what went wrong. From that to like even console log, you remotely just attached to a running system and it gives you entire history of the console log. Simple things from that to how like you can detect slow drives, bad network. They are all not someone else's problem, right? Almost always that you will then see a slow drive, a batch of new drives are slow. You would actually end up blaming MinIO, that MinIO is slow and timing out or unstable. Then this, you can't really throw people at this problem to debug and troubleshoot. It's not a scalable approach, right? This is where the supportability capabilities that we are adding into the system will actually enable not only the users but also us to reduce the burden at scale. That we at this pace, we make new releases every week, sometimes even multiple times a week. We are able to move fast and almost operate private cloud deployments on par or better than public cloud deployments. These guys are able to run large infrastructure with no previous storage experience, right? That is, to me, enabling them as part of these tooling is super important. Then followed by other feature that we are adding is subnet. Subnet is how we can remotely help these users, lifecycle management, then ability to expand clusters on demand, things like that. But in general, I would say we are the anti-roadmap company. I always tell our architects and our users that if you send a pull request to remove a feature, I will immediately accept it, as compared to adding. Ask 10 times before you really need this feature, because adding is easy, maintaining is expensive. We try very hard to not make it feature rich, and that will be that will lead to the collapse eventually, right? So being very particular about making sure every feature out there is a very important part of the system. So that's about it.
Are there any other aspects of the work that you're doing at MinIO or the overall space that you're working in that we didn't discuss yet that you'd like to cover before we close out the show?
I think in general, I see that like object storage has come a long way. I would like to see like more like tools on top. Like for example, better data governance. Data governance itself, I think, is a data governance, data management, are kind of a old school thinking. Like it's not. I'm not thinking in those terms. The real problem is actually your data is at such large scale and is constantly changing. Now ability to control access, define policies, even establishing identity, like those days you want to give access based on user IDs. Nowadays there are no users, these are applications, and you need application identities. Applications cannot actually do two-factor authentication, right? They need to be doing certificate-based authentication. From things like that to how you define application policies and control access to data and APIs. A lot has changed in the recent times, and industry is far behind in terms of their understanding of how to manage data on object storage, how to establish these identities, and then also even discover data, right? When you have data getting generated faster than all of your past data, how do you then even organize this data, cataloging them, or indexing them, or putting them in like organized folders and buckets is just going to be impossible. The way then you have to look at it is, think of this problem as a search problem, right? Like if you have too much of data, you can't organize them as folders. Then all you need is a better search engine, better access mechanism and policy control, all that. I think there is a lot of room for these kind of powerful tools to emerge on top of the data management, data storage system. I would like to see more new projects or startups going after them.
For anybody who wants to follow along with the work that you're doing and keep track of the work that you're doing, I'll have you add your preferred contact information to the show notes. And you've touched on this a little bit just now, but I'd still like to get your perspective on what you see as being the biggest gap in the tooling or technology for data management today, if you have anything else to say on that matter.
Yeah, I think to summarize that, it's the tooling is the search part, the access management, and in terms of policies, access management. In the past, because you had many different storage systems, like trying to do unified data governance on top of a variety of like SAN NAS vendors and database vendors was hard. This is where the data lake got all the bad rep, right? And in the new world, the good part is all of the data is getting consolidated to object storage, and there is only one storage system at the heart of the data infrastructure, and everything else is simply stateless containers and VMs around object storage, and they are all accessing through S3 API. If this is the case, finally data management is something tractable, right? But then the key here is the old school data management model does not work here anymore. It has to be fundamentally rethought in the form of a search and access platform. I haven't seen a good product yet in the market, but certainly I keep hearing new startups wanting to go after this market.
Well, thank you very much for taking the time today to join me and discuss the work that you've been doing with MinIO. It's definitely an interesting project and one that I have been keeping an eye on for a while and looked forward to using for my own purposes. So thank you for all of your efforts on that front, and I hope you enjoy the rest of your day.
Oh, thank you, Tobias. This is a common pattern we see, like users use us in their home NAS or just the home drives, and also in the corporate on large scale machines. For me, that is the real proof for me that it has delivered what I wanted. When it is simple enough for a personal use case, that level of simplicity is what is needed to actually operate a very large infrastructure, right? And often I see that when we talk to our users, it is even running on their laptop and home NAS appliances. It's cool to hear that.
Thank you again, and have a good rest of your day.
You too, Tobias.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.
La 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 la